Okay. Okay. So you can see the slide.
Yes, sir.
Yes, sir.
Okay. So today we will discuss about the molecular weight determination. So this particular method is used to determine the molecular weights of individual, you can say the protein bands. Okay. So here I have taken this gel. Okay. So now to determine the molecular weight, let me open this. See whether you are running agarose gel or you are running SDS page gel, always you are to run a standard marker. Okay. Say for example, this is our gel. It may be agarose gel or it may be SDS page. Okay. And here you say, so this is the one band. One band indicates the protein. Okay. So this is one protein. Then again, this is another protein. Okay. Fine. This is another protein. Okay. Fine. So likewise, you have this protein, and along with this test protein, you have run this test protein from say here. So here you had the well. From the well, you loaded your sample, and then this proteins they were separated. Okay, or DNA they were separated. So along with this, your test protein or test DNA, you also should run one standard marker. Okay, so standard markers they are also called. There are many ways how we call them. So one is called marker. DNA marker or protein marker. DNA marker is for agarose gel, protein marker is for SDS page. Or sometimes they're also called ladder. Okay. So these protein markers or ladders, so these are the fragments of the protein or the DNA that is supplied by the company. These are commercially available. Okay. And in their leaflet, they will tell what is the molecular weight of each and every band. Okay. So what happens? Say for example, uh, let me put a red color here. So this way, so this is this the first lane. It is the marker lane marker, and second lane is the test sample. Okay. Now let us assume that this is a SDS page. Okay. So if it is SDS page, then these are different bands of the. That means your sample had four number of proteins. Okay. And now you have to find out what is the molecular weight of each and every band that is present over here. Okay. So for that reason, we always run along with the test sample, we run a marker. Okay. So if you look into the leaflet or any kind of booklet provided by the company from where you have purchased the marker, so they will tell what is the molecular weight of this band, this band, this band, and this band. That means these molecular weights are known. So we can call them standard protein markers. Okay. So for example, let us assume that this particular band, say it has got, let us say that it has got, say 80 kilodalton. Okay. It has got 80 kilodalton. Then this particular band, it has got say 70 kilodalton. This one has got say let us say 58 kilodalton. This one, just assuming it, this one is say 40 kilodalton, and this one is say 20 kilodalton. Okay, fine. Now, how you know that this is 80, 70? So this you don't have to know by yourself when you will purchase the marker. So in the this information provided by the company, there itself it will be mentioned that the above band will be the 80 kd like that. Okay, so here I am putting this 80, 70 just like that only, just arbitrarily I am putting for your understanding. Okay, now to know what is the molecular weight of this particular band or test band, what you can see is that these two bands, this 80 kd band of the marker and this band, they are coming together. Since they are coming together, this means that this particular band is also 80 kd. Okay. Similarly, you find that say this particular band, it is little bit above 58 kd. So when it is above 58 kd, that means it is more than 58. Say it is approximately 60 kda. Okay. Then this band, it is just above the 40 kda band. That means it is say 42 or 41 kda. So this is how you can determine. Okay, you can determine uh, the molecular weight of the test proteins. Okay, but here there is an issue. So we have an issue over here. The first thing is that because this band is okay, it is coming exactly with the same line with the 80 kd, but this band, it is above 70 kd. So you have to find out what is the exact molecular weight. Okay, so from here you can just arbitrarily can tell that it is say 75 or 72 kd, but you cannot tell exactly. Okay, so today I will show you how to determine the molecular weight of the test, this protein band of a test sample. Okay, by comparing with the marker. So this way, as I compared now, so this is an arbitrary method. Okay, but we will have to use the proper method. Okay, so for this, what we will have to do, so this is the marker. Okay, in this gel, this is the marker and this is the protein. So they are calling it a BME. So BME is a protein. Okay, in this I got this photograph from a particular paper. So they have used this particular protein, okay, to determine its molecular weight. Okay, so now what you see is that in this particular uh, page. So number of bands that you are seeing over here, all these bands, they represent one or two proteins. Okay, fine. So now we will be concerned about this particular band. You see that this particular band is quite dark. So I told yesterday, I discussed earlier that when you have a dark band, this means that protein is present in large amount. So this protein has got high concentration. That's why the band is quite dark. Okay. Now our aim is to calculate the molecular weight of this band. Okay. So this is a protein marker, and these are the molecular weights of these markers. This these are the molecular weights of the bands of this marker. Okay. So now based on this, you can see that this is just above 25, so it is more than 25, but it is below 35, that is less than 35. Okay, so now, so this is the distance I have measured. Okay, so what I have done is that just if I go back to my whiteboard, so what we do to measure the distance. So first of all, we will measure the distance, how much distance the band has traveled from the well. This is the well origin. You can see because you loaded the sample here. So this is the origin. So from the origin, how much distance or how much distance the band has traveled. So we generally measure this in millimeters. Okay. Say from here, how much distance it has traveled. Then again from here, how much distance this band has traveled. From here, how much distance this band has traveled. So likewise, so we'll calculate the distance traveled by each and every band. Okay. So obviously, this band will be having less distance. The smaller band will be having more distance. That means the smaller band has traveled more distance. Okay. So based on that, we will make a table. In this table, the MR stands for molecular weight. You can see this is 100. I have not used the 180. I have started from 100. So from 100, 75, 63, like this, we have made a table. And this the band 100, it has traveled 11 millimeter. 75, the band having the molecular weight of 75 has traveled 22 millimeters. So like this, we have made a table. Okay. And then now what? Okay. Then what we will do is to make a standard curve. So standard curve means what we will do in the x-axis. Okay, we'll put the distance migrated. So how much distance it has migrated, and in the y-axis we have the log of molecular weight. So what we will do? How we'll determine the log of molecular weight? This is the 100 is the molecular weight. You can just calculate the log of the molecular weight. Okay, and that you are to put it over here. So instead of putting molecular weight, you have to put here log of molecular weight. Okay, so that means now we will make a. So that means now we will make a graph. Okay, so here we'll take the log of log 10 of molecular weight, and here we'll put how much distance it has traveled in millimeters. Okay, so we'll make a standard curve like this. Our standard curve will go like this. Okay, fine. And then thereafter what we find is that we want to find out the distance traveled by this particular band, not this particular band. So it is found that from the origin this band has traveled 115 millimeter. Okay, so what we will do now, here suppose this point is 115 millimeter, and from here you just make a straight line. Okay, then again make a straight line. So now wherever it is touching, so that point is the log of molecular weight. So you understand that this particular band which has traveled this particular band which has traveled the 115 millimeter, it will be having this much of the log of molecular weight. Okay, then you can take the antilog and you can find out what is the actual molecular weight. Okay, so this is the method that is called the standard curve method, but this method has got a lot of drawback. Okay, so first thing is that it is time consuming. You'll have to make the graph and all these things, then just you'll have to use a scale and draw the straight lines, and also whatever result you will get, that result will not be accurate. Okay, so we have another way. Instead of standard curve method, we have another method. So that is called regression analysis. Okay, so now regression analysis, what we do here, let me open another. Okay, so in regression analysis, so you are familiar with this term. So in regression analysis, you have two things. So one is called independent variable, or is also called predictor variable. Then second one is the dependent variable, or is also called response variable. Okay, so now what is independent variable here? Because here you have two things. One is the distance traveled. This is one variable, and second variable is the molecular weight. So in this case, we are not taking the molecular weight, we are taking the log n of the molecular weight. So now you have two variables. Okay. Now you see, our aim is to find out the molecular weight. Our aim is not to find out the distance table, because distance, how much your band has traveled distance, you can measure by scale. But your aim is to find out the molecular weight. So think the variable which you want to find out, which should determine. So that variable is called dependent variable. Okay, the variable that you will determine, that is called dependent variable. Okay, or response variable. And the variable that you have, because in case of test sample you don't have the molecular weight, but you have the distance travel. So distance travel you have, so that is why it is called predictor variable. That is, this variable will help in predicting the molecular weight. That is why it is called predictor variable. Okay, so now in case of regression analysis, I think you must be knowing about this. Y is equal to m into x. I will say that mx plus e. So this is a common thing. Okay. So here the y is the dependent variable. Okay. And the x is the predictor variable. Okay. So now in the regression analysis, okay, we will determine the value of the m and c. That means if you know the value of the m and c, so what you can do is that, because your aim is to find out the molecular weight, so y is equal to m is the slope, m is the that you will determine, okay, then into x, x is the distance traveled, it is already known to you, plus c. So m and c, they are constants. Okay, just put this for just put your distance traveled in this formula, you will get the molecular weight. So in regression analysis, so your aim is to find out m and c. So these two things we are to determine by regression analysis, and thereafter just put it in this formula, you will get the result. Okay, fine. So here I am talking lots, so it seems to be quite difficult, but it is not difficult. So what I'll do, first of all, I'll show this how to do it in the uh, Excel. Then I will show you how to do it in the R. So I'm opening the Excel sheet. Okay. So here, so this is the, okay. Can you see the Excel sheet? Okay, fine. You can. Okay. So here, okay. This is the molecular weight, and this one is the distance traveled. Okay, that is in the millimeters. Let me just make the fonts short. Okay. Okay. Now our next aim, Okay. So our next aim is to determine the molecular weight of our test band. But before that, our first aim is to determine the value of the M and the value of the C. Once we determine this, then it will be clear that how much that we just put the value of the distance in there and you will get the answer. Okay. So for this, what we will have to do, because this one is the molecular weight, but we'll have to convert it into log 10 of the molecular weight. So how we are going to do this? So I'll just copy this again here and traveled. Okay. And here I'll make another column log 10 molecular weight. Make the heading here. Now what I'm going to do is that in Excel, it can be determined very easily. Just put equal to sign. Okay. Then log, when you type log, it comes by itself. So here log 10. Just click in the log 10, then number. So just click in the first cell 100. Okay. And press enter. That means the log 10 of 100 is 2. Okay. Then I just drag it. Just drag it. So all the values, this 100, 75, it is 1.8. 63 is 1.799 something. Okay. And your 17 is 1.2. So this is how you determine the log 10 molecular weight of these values. Okay. Now this is one. From here we'll do the regression analysis. Okay. So now we have already discussed that you have two types of variables, x and y. Okay. So just go back here. So what you see, the distance traveled is the predictor variable, that is the x. Okay. And the log 10 molecular weight should be y. So now what we will do, just click in the data. Okay. Once you click in the data, in the right hand side, you will get one option called data analysis. Okay. So this data analysis may not be available in your Excel sheet. If it is not available, if it is not, if you don't find this here, what do you do? Just if you're using 2007 version, then you have to click the window version, window that icon here. Otherwise, you can just click over here, file. Okay, then go to the options. It's same in all Excel sheet. Okay, then click in the add-ins. You click in the add-ins. Okay, and after that, Excel add-ins here, downside here, click go. Now you will have to check this analysis tool pack. So that means normally what happens, this remains unchecked. In my case, it is already checked because I have already done this. So if you don't find data analysis, then you'll have to click the analysis tool pack here. Click over here and click OK. Okay, then this will appear after some time. Okay, now we click the data analysis. Okay, so here you just go down, you will find regression. Click regression. Click OK. Okay. Now you see it is asking for y and x. Okay. Now you see the y means the variable which you want to determine. You want to determine the molecular weight. So I will take log of molecular weight as y range. I'll take it here. I'll just, so here what is to be done? Just put the cursor here. Okay. And then select the whole column. Okay. Then click in the X, select the distance traveled. Now you tell the Excel that first, the first row is the row of the label. The log 10 molecular weight distance traveled, this is the label. So click label. So you will understand that first row is label row. Okay, fine. And then click OK. So once you click OK, just a minute, there is some problem here. Let me try it once again. Data analysis, regression. Okay. Yeah, now. So it was wrongly selected. So actually, what mistake I did in the first case. So in the first case, like this constant is 0 was checked. That's why it was giving the mistake. Okay. So now let's go to this one. Okay. So this is the regression output that you got. Okay. So here, what is important for us is this particular column. So in this column, all the things are not important, but only few things are important. Okay. So you see, this is intercept. So intercept is the value of the C. Okay. Then you have the M, because we needed two things, M and C. So what is M here? Okay. So this value, okay, this is M. Fine. So intercept coefficient is the value of the C, and distance traveled coefficient is the value of the M. So it is okay. Now just put these values here. Let me go back to my earlier. So here what you find is that what has happened? I think I've copied the wrong thing. Okay. So intercept is 2.07188 and distance traveled. So this is the value of the M, and this one is the C. So value of C is 2.01 something, and the value of M is minus 0.0057 something. Okay. Now our aim is to determine the molecular weight of our test band. So now your M and C value is with you. Okay. Now if I just go to my PowerPoint slide. So here you can see, so this is our test protein. So test band, it has traveled a distance of 115 millimeter. Okay. So what I'll do, because here, let me put it over here. So now the value of the M is equal to minus, let me take a short form. So this is the value of the M. Okay. And then now the value of the C is equal to, sorry, 2.017. So the value of C is 2.017. This is the value of the C. Now we want to find out the value of the Y. So Y is the log of molecular weight. So remember that Y is not the molecular weight. Y is log 10 molecular weight. Okay. So Y is equal to log 10 molecular weight. Okay. And that is equal to mx as this one, mx plus C. So M is minus 0.0057. Okay. Then into x. Now what is x here? So x is the distance traveled by the test band in this case. So here The test band has stable distance of 115. So it is 115. Then plus C plus 2.017. Now, this is how we are to determine the log 10 of the molecular weight. Okay. So let me try, let me calculate this in the Excel only. So if I just try to calculate this in Excel, so I can just is equal to minus 0.0057. Okay. Then into the star is the into here into 115. 115. So let me put the bracket, complete bracket, then plus intercept 2.017. 2.017. If I just put the enter, well, I get the value of 1.3615. So I get the value as 1.3615. So now what is this value? This value is not the molecular weight. It is the log 10 molecular weight. So I would say that log 10 molecular weight is equal to 1.3615. That means this particular band, its log 10 molecular weight is 1.3615. But the problem is you are not supposed to describe the molecular weight as log 10. You should describe it as molecular weight only. So how to remove the log? To remove the log, you have to take the antilog. So how will you take the antilog here? So to take the antilog, what simply you will do 10. That means simply I'll say molecular weight is equal to 10, then raised to power 1 point. If I just write it in this smaller way, 1.36, 1.3615. This is how you take the antilog. That is molecular weight is equal to 10 raised to power 1.3615. So if you just this particular value 1.3615, we just put it as exponent above 10. So whatever value you will get, that will be the molecular weight. This is how we determine the antilog. So in Excel, how you will determine? So Excel, what you will do? In Excel is equal to 10 raised to power. So above 6, there is a sign. This kind of sign is there. Let's put that sign. Okay. And then 1.3615. Just enter 22.98. Okay. So what you find is that the value of this is 22.98. Okay. So this is the molecular weight of this particular band. Okay. So it is 22.98. This is how we calculate the molecular weight. Now here the thing is that you don't have to draw any graph, nothing. Okay. So it is very easy because I'm just because I'm taking the class, so I'm taking a lot of time. But when you will do it by yourself, once you get through it with this one, so you can calculate the molecular weight by yourself. Okay. Now the thing is that once you know the molecular weight, So now you can just search in the internet. Okay, the 22.9 kilodalton. This is the molecular weight. Now, which protein has this molecular weight? Okay, so you will get in the net you can search, and then through that literature search you will come to know what exactly this protein is. Once you know the molecular weight, you will know what protein it is. Okay. So similarly, if you want to know each and every proteins present over here, so just because uh, you have already obtained the value of the M and C. So M and C value you will obtain by marker, okay, by using regression analysis. Then put that value, the distance value in M and C of all these things. Just you calculate the distance from here to here. Okay, so whatever distance come, put it into that formula. It will tell you what is the molecular weight of this band, this band, this band, this band. So all the bands you can calculate the molecular weight, and then you can find out that what are the different types of proteins are present in your sample. It's a crude way. So to confirm that this protein is that this particular band is for that protein, so you'll have to go for one technique called Marlitov. So Marlitov, actually we don't do it here. We use it for outsourcing. Just you have to cut. Suppose you want to know that you have found that this is the 22 kilodalton molecular weight. Now you just cut this band from here, cut it from here and send it for Marlitov. There are a lot of companies they are doing this, okay, and then they will tell you what protein it is. You can determine the identity of protein by using Marlitov. But if you don't have the fund, if you don't have the money to carry out Marlitov, so by just determining the molecular weight, also you can find out what protein it is by the literature search. You can just search the literature, okay, that 22 kd per protein. If you just put it in the Google, that 22 kd proteins, so you will get list of proteins which have the molecular weight of 22 kd. Okay, then you can just think that which protein is more appropriate. Okay, say for example, you are getting a bacterial protein, but you know that this is not a protein from bacteria. It is obtained from, say, poultry bird. So that definitely that protein is not the one that you are looking for. And you first and just see other proteins and you find one protein having 22 kd molecular weight, and that protein is from poultry. Then you can see that this protein could be that protein which you have uh, 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 searched through literature. Okay, so this is the way how we do the this analysis in the how we do the analysis in Excel sheet. Okay, and I'll show you how to do the same thing in the R. Okay, so in the R, the things are a bit easier as compared to Excel. So I think you are already familiar with the R. Okay, so just remove all this stuff. Okay, so this is the console where the commands are executed and you get the result over here, and this is the R script. Okay, so here to type the commands. So actually the typing of the commands is not required every time. Once you type the command, and you can store these commands, and next time you don't have to run it again. Just you click run, it will run. So now let us say that we have got two variables. One is the molecular weight and another one is the distance travel. So I will call the molecular weight as M. Let me write it as capital M. Capital M is equal to, now I put the small c, okay, and put a bracket. Okay, now I'll start putting the values over here. So let me put the values over there. So first is 100, comma, second is 75, comma, third is 63, comma, fourth is 48, then 35, 25, 20, 17. Oh, sorry, 17. Okay. And I put enter. If I just type M, oh sorry, one thing is there. So after I have written this one, okay, then okay, I'll put enter here. Okay. Now I write the second variable. Okay. So my second variable is distance traveled. Okay. So I just write it as D. D distance traveled is equal to same thing, small c bracket. So I'll write 11 comma then 22 sorry 22 comma 35 comma 55 comma 82 comma 110 comma 125 comma 140. I did it. I made the script. So the M is for the molecular weight and D is for distance traveled. Move it. Okay. Now the next command is I need to create a regression analysis. So I will name this regression analysis as REG. This is the name I'm giving. I'll say this course is VBC 712. I name it as VBC 712 regression is equal to. Now for regression analysis, the command is like this: small l, small m. Then put the bracket. Now here, first of all, I will have to put the dependent variable. So you know that the dependent variable is molecular weight. So in this case, capital M. Capital M. Then versus capital M, then versus D. Okay. So the formula is like this. First of all, you have to put the dependent variable. Then you put this sign. So this previous sign you will find in the right side extreme left corner, upper left corner. This side. Okay, and then write the D. Okay. The thing is that if I put enter here, so this will do the regression analysis between the distance traveled and the molecular weight. But remember, we don't want the molecular weight. We want log 10 molecular weight. So for this, what we will do, just M is there. I'll write it as log 10 M. Earlier I put M versus D. Now I put log 10 and the bracket M versus D. Okay, fine. And thereafter, summary. So this is the VBC 712 regression, okay, which you have done. I'll write the summary here. Okay, this is the commands I have written. Okay, now I want the execute. How will I execute the command? Okay, so just put your cursor here. So first, this is the number one command. M is equal to C100. This command I need to execute. To execute the command, I have to put the cursor in the command line and click run. If I click, let me give a gap here. So if I just put the command, the cursor here and click run. So you see in the console it has run. Okay. Then I put the cursor here, click run here, it has run. Okay. And if I want to see what is M, okay, so I'll write simply M here and run. You can see the molecular weight it is showing here. Okay. Similarly, if I just write capital D here and run, so it is showing the distance. Okay. So that is okay. Now I want to run this command. command of the regression analysis. So just put it here and I click run. I have clicked run. So that means the system has run the regression analysis. Now I want the summary. So now in the summary, just put this summary is also a command. Put it here, cursor, and run. So you see, this is the regression output. Okay, and you see, remember that in Excel, the intercept you got it as 2.017. Same thing is here. Okay, and the D it is showing the value of the M. So this one, the intercept, this one is the value of C, and this one is the value of M. Okay, so here it is showing D because I have named it as D. So it is easier as compared to Excel. Okay, and when you do the regression analysis, so what are the things you have to see? First thing is that this intercept and this slope, okay, you should have at least 1 star. So you have 3 star, that is the best. Then you should see that the p value should be less than 0.05. So it is 7.481. That means it is 7.4 into raised to power minus 7.4 into 10 raised to power minus 8. It is very, very less. Okay. Then you should see the r square value. It is 0.99. 0.99 means 99%. It is the best one. So it should be more than 75%. That means it should be more than 0.75. So it is good. Okay. So now, after seeing all these things, everything is okay. Then you take this value as C and this value as M. Oh, sorry. Yeah. This value as M and this value as C. Okay. Fine. And then after that, once you get the value, okay, say how much value we got earlier. Say we got 1.3615. Okay. So 1.3615 we got. Okay. Now you want to find the antilog. So same thing you can calculate here also. Just write n raised to power 1.3615 as we did the calculation. Okay. Then now so now this also becomes a formula. Sorry, it is also a command now. So now just click run here. This gives the result here. This one. 2.978. Okay. So now this is the value of your molecular weight. Okay. So for this purpose, for regression analysis, I always prefer the R because R is easy. Okay. But Excel is a bit difficult. So that's why I use this. So